Hello and welcome back to the next part of my series in assembling the RC2014 Pro. We've built 5 modules already, so that's the Z80, RAM, ROM, the compact flash card and the clock card. This is the final card, and this is the serial I/O card. It will enable me to connect to my PC using an appropriate adapter, and it will provide my RC2014 Pro with 2 serial ports. You can see port A here, port B here. This is a fairly straightforward build. It looks like we've just got to put an enhanced bus on here, which I'll need to trim, 3 sockets, which thankfully is all I've got left over here, and these 3 chips, a 04 hex inverter at the top here, and a 138 decoder, presumably for decoding the address lines, and the Z80 SIO itself. Now, I've not used a Z80 SIO, you'd be surprised to hear. I've used UARTs before, so I expect this works in a very similar fashion. But it's been designed to, specifically with the Z80 in mind, it being part of the Z80 peripheral family of chips. Anyway, I've got all of the components I need here now. I've got my 6 1K resistors, right angled headers for 5 volts, the 2 serial ports and 2 5-volt lines here. Oh, and the port B clock. And yep. What you see is what I need to assemble. So I'd better crack on with it. I'm going to start off first with the tedious bit, which is trimming the dual right-angled header here for the enhanced port. So I've got to trim 16 pins here and 4 at the end, so it's the 3 here and the one I'm going to chop off. And I think that must leave 20 pins here in the middle, which I'm going to leave. So yeah, I'm going to fast forward this bit. I'll see you at the other side of this fast forward, and yeah, let's get cracking. And there we have it. Hopefully this will fit now. Yep, that's perfect. Not missed a pin. Excellent. So I'll get the soldering iron warmed up, get this header straight and soldered in, and I'll see you at the other side of this fast forward segment. Okay, that's looking pretty good. Happy with that. No obvious shorts. Made a bit of a mark there on the board where a bit of solder flicked up, but it's on a ground plane, so it's not going to make a bit of difference, it's just cosmetic. Yep. Let me see, what shall I solder next? Yeah. I could do the resistors, I suppose. Yeah, let's do the resistors next. Get them out of the packet first. There we go. Easy just to. There we go. Saves mucking around trying to. Got to be trimmed anyway, aren't they? There we go. And there. Right. Can I gauge these at? Just trying to work out where to bend the leads. I think if I just use about that much of a bend, so about a couple of millimeters in to the lead, should be about right. So it looks like so. Let's try that. How does that work for gauge? That is absolutely perfect. Brilliant. So I'll prepare the rest of those, get those soldered in. Yeah. So I was thinking last night, I thought, well, I've got a lot of experience using the H250, I think it is, which is the IBM PC. The PSX uses that. It's the IBM x86, I think, favoured. UART, Universal Asynchronous Receiver and Transmitter. What they usually do is, or what they do is enable you to input a signal. So I'd stick a value on a port, I guess. There'll be a couple of ports allocated for reading, one for RX transmit, no read, one for TX transmit, send, and the idea is you stick your digital value in there from the Z80 in a port. As I say, I want to write the value 65 out. I put 65 into the port, having set up the SAO in software via other ports, and the serial IO chip would take care of sending that out as RS232 at whatever specified baud rate I'd set it up, and start and stop bits and all of that stuff. So I assume this works in the same fashion. There'll be some port for setting it up, so setting the baud rate and all that jazz. There'll be baud rate, start and stop bits, number of data bits, 7 or 8, and there'll be a port for the transmit byte, a port for any bytes that have been received from the outside world back to the UART, and I think that's it. I can't remember. Is there a port you read for? I should know this, having written the code for the BSX. There may be a port that you read for status as well, only if there are any bytes available to read on the bus, because obviously you only want to start reading a byte when something from the outside has put a value on there. Right, in fact, just hold on 1 second. Oh, here we go. So this is the bit that converts USB serial protocol via this chip here to RS232. Is it an FTDI chip? Probably they usually are. So this will convert the 5 volt USB serial voltage. It'll appear as a COM device when I plug it into the USB port of the PC, and if I write data out to it, it will send out on this port here serial information that's been written out, I guess, and it will receive data back. So that, I assume, will plug into the right angled header here for port A once I've soldered it on via that block there. So it'll connect to the USB port of the PC. There'll be that board to convert USB to serial, and then that's it. I guess there's code in the ROM for handling keyboard input and outputting data back to the terminal. I'll be using something like Putty for the terminal software. Old favourite of mine. Used it for many years. way before I started doing this kind of stuff with USB protocols. I did a work a few years ago for a company called Space Track that used a Panasonic satellite modem, KXG 7101 if memory serves me correctly. It used to send data over a LEO constellation, low Earth orbit satellite constellation. Was it the Orbcom network? The Orbcom network. And the only way you could talk to this modem was via a serial console. And we're not talking USB here, we're talking proper RS232 port, 9-pin D socket. And yeah, PuTTY was my tool of choice back then, and it still is now. Yeah, so there we go. So I've soldered, well, I've mounted the resistors, all pointing in the same direction. Don't have to be, they're not polarized, but it just looks nicer. I'll get these soldered up. I'll skip to fast forward for this bit. Okay, what should we do next? Let's do the chip sockets next. All of the chips are pointing that way. So let's start off with the big one first. It's a 40 pin, this, isn't it? Looks like a 40 pin one. It's the same size as a Z80. There we go. So let's get this fella in first. Right, let's do the usual. So the diagonally opposite pins, make sure the socket's level. Soldering iron's cooled down a bit there. Come on, you can do it. There we go. Oh, it's looking pretty good. Yeah, so going back to Space Track, that was a pretty good gig, that. I was programming the modems in C, I think it was. There was a 64K block of memory which was separate from the satellite block, which basically provided the firmware. I think it works the same way that modern tablets and mobile phones work. There was a CPU, and then you talk to the modem using AT commands. Yep, AT commands, just like a dial-up. Very, very interesting piece of hardware. It wasn't the only modem that the Orbcom network supported. There was one by a Israeli outfit, I can't remember the name now, that used an Atmel chip, and you could program that in assembly language as well as C. We never got around to using that one. Yeah. Anyway, so back to serial I/O. I've been doing serial communications in hardware and software for as long as I can remember now. I think I perfected the art in software at Barcrest, fruit machine manufacturer. And then from there, took it to the next level at remote area networks. I've been using it on and off to control things, industrial devices, probably for about the past, well, 25 years, something like that. 25 years. RS232, RS485, and then obviously other protocols have come along, like I2C. I think once you've grasped the principles of serial communication, doesn't really matter what's happening at the hardware level. You know, your software is basically all about sending data and receiving data and doing some kind of handshaking to make sure that you don't rush things through or miss data. and you know, some kind of way of check summing it to make sure that the data you've received is valid, especially important on industrial and automotive comms. Making sure that the data you've received is correct. So that's usually a CRC and a sense check. I'll be programming this at some point because I'm hoping to get BBC Basic for Z80 either running via CPM and or on a ROM image for those that have the non-CPM versions of RC2014 boards. Okay, so that's that done. What have we got next? Got two chip sockets here, both pointing left again. So make sure we get the notch in the right direction. Let's do the bigger one first. Notch to the left. There we go. Let's plunk you down there. Tell you what, I'll fast forward this bit. I'll see you at the other end. Okay, that's looking pretty acceptable. So now we need to cut the right angled header pins now. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 6s and 3 2s. So hopefully there's enough on here for me to do that because I don't have any of these spare. This is what I've been supplied with anyway. So let's do the 6s first. 1, 2, 3, 4, 5, 6. So just nip there. 2, 3, 4, 5, 6. There you go. That's an example of me measuring twice and cutting once. That's what my old man told me. Oh, come on. Don't want to break these. There we go. That's 1 6. Do one more 6. 1, 2, 3, 4, 5, 6. There you go, so another 6. And I do have 3 2s there. Not too much and not too little. So there's a 2. Or do I? I'm one short, aren't I? Have I measured something wrong there? Oh no. Okay. No worries. I can recover from this. I don't need to put all of them on. In fact, I can use a... I've done this right. Yeah, it's definitely a 6, isn't it? Ah, nuts. It's got a 6, 2, 2 2s and a 1. I thought I had enough for everything there. Maybe I've soldered a pin on somewhere I don't need to. Ah, never mind. What I could do is... not work. One of the spare ones there are. I'll tell you what I'll do. It's not in here, is it? Okay, I'll solder what I've got and I'll come back to... I'll put the 5 volt ones on. The clock one I can probably leave until last. Okay, nowhere to be seen. So what I'll do is I will solder, looking at what's required here. I'll solder everything apart from the 5 volts for port B. And I'll come back to that. I don't think that's required. There's no jumper on the image I've got here. Yeah, and I'll order some more right angled headers. Get that done. Okay, never mind. These things happen. Right, let's get soldering then. Yeah, let's do this one first. Hopefully it'll be nice and flat. Clean one's tip. That's where I burn my fingers probably. Let's push that one down. If I've used a right angled header somewhere I shouldn't have done. I'll check the other boards in a minute. Oh, come on. Temperature up a bit. Make sure that's level. I'll just give it a quick. Oh. Bent in a bit there. I think it was more or less perfect first time round. Yeah, that'll do. That will do, pig, that will do. Now let's do the second one. So again, I'm just tacking it in left and right, because then I'm going to, with my asbestos fingers, get it level. So let's just, yowzers, that's hot. Level it off. This one's proving a bit more troublesome than the other one. Hang on. There we go. A bit more. Yep, that will do. That will do nicely. Perfect. That's 2 done. Let's just have a quick look at these other boards. I mean, that's using straight pins. That doesn't use right angled. That's straight pins for the jumpers. Clock module. I'm pretty sure that's supposed to be right angled there. That doesn't have any. Neither does that. Let me just check the manual for that. Yeah, that's fine. That's as it should be. That's the only other place where right-angled headers are used. Maybe I should have not soldered that on, and that's left me short. Anyway, what's done's done. I'll get some. I needed to buy some right-angled headers anyway. So now, which ones did it say I was going to solder on again? Let me just check the instructions. I was going to do the port A clock and port B clock, but I wasn't going to do the 5 volt. That was it. So I'm going to solder, no, port A 5 volt, port B clock, and I was going to leave this 5 volt out, I think. Yeah, I'll have to, won't I? Blue tack will be my friend here, just to keep these things straight. Must have soldered them in. Let's do port B clock first. Get it level. There we go. Tip my hat to the man that invented blue tack. Fabulous guy, Mr. Blue Tack. It's literally a helping hand. So let's get some heat on this. I wonder if there's a medical application for blue tack. There's a, you know, like cling film was invented to, was it in the Vietnam War or something like that? Oh, that was hot. As a kind of a field dressing. I wonder if it was same as true of blue tack. Oh, it's not level at all, is it? That will have to do, as they say. That's close enough. What was the next one? We can always bend the pins, can't I? It's this 5 volt one here, isn't it? So, put the soldering iron down before I do myself serious injury. I'll get this one in first because it's a bit fiddly. Yikes. There. Just tuck that in gently. Perfect. And solder it without disturbing too much. Yeah, so, you know, cling film was a field dressing, wasn't it, in the Vietnam War, and then they decided to use it to preserve food. You know, if you got burns, just wrap people in cling film. Or the idea of having burnt skin, loose skin, and then peeling the cling film off doesn't sound very appealing, but I'm sure it prevents the fluid loss that's normally associated with serious skin burns. There you go, it's not just about soldering. I really should stop talking about serious skin burns whilst handling the soldering iron. I'm probably tempting fate, aren't I? Oh, come on. You are hot enough. There we go. Oh, it's bent in a bit. Bend it out again. My obsession with getting things straight is going to lead to sore fingers. There we go. That will do. And I'm going to leave that one until I've got another right-angled header set. But assume for the moment, if I had the part, I'd solder that in. So TLDR is, if you're building the Pro kit and you realise you're one of those short, you've probably done exactly what I've done. And, yep. Unless, of course, it's in here. No. That would be too convenient, wouldn't it? That would be way too convenient. Should I budget with a single one? That's probably going to be a bit weird, though, isn't it? There's a different bit of plastic. I suppose, couldn't I? Nobody would know. But I wouldn't know. No, I need to get some anyway. Let's do this properly. So finally, I've got to get the chips in. There's 3 chips. There's the big one, 2 small ones. Let's start off with the 2 small ones. So we've got a hex inverter, which is 04 here. Let's get that fella in. Notch to the left. And there we go. That's definitely the right one, isn't it? 04 in there. There we go. And then there's the, at least I've not run out of chips. That's the main thing, isn't it? I can cope with everything else. Let's bend that in. The multiplexer chip, is it? Or no, it's a decoder chip. Same difference, I think, in this instance. So that will be asserting probably chip select when upon some hardwired condition for the address bus. So presumably, looking at this, there's no jumpers. It's hard coded to an address on the bus. Yeah. Right, last chip, last but not least, last bit of chippery, this part of the build anyway, is this whopper Z80 serial IO chip. I'm amazed they still make Z80 chips and peripheral chips, you know. Having dealt with Z80 and Z80 base machines for since I was about 12, so that would be early 80s, you know, ZX81 onwards. I think by the time that I'd stopped programming the Spectrum and had moved on to the Game Boy and the NES and other consoles like that, I'd really written the Z80 off, but yet here I am, soldering a Z80 peripheral to a board. Anyway, enough of my waffling. With the exception of that header pin there, that's the 6th and final board done. Next will be, let's get them all out in their magnificence. There we go. Next will be the header board. So stay tuned for that. I hope you've enjoyed watching this video. There'll be a link at the end for the playlist for this series of videos if you want to catch up on any of the builds for the other boards, and a link to the next installment, which will be soldering up the backplane, which will connect all of these boards together. I'll see you in the next one. Thank you very much for watching. Goodbye.